Okay, in this next lesson, I'm going to look at absolute value equations and inequalities. So the biggest thing we need to understand with absolute value is that it's really our distance from zero on a number line. So I'm going to start by attempting to solve this first absolute value equation by using a number line. So first of all, I'm going to just sketch a number line, and then I'm going to put some markings on here for different numbers. So we'll we'll start off at 3 because there's 3 is in the middle here. So we'll say 3, 4, 5, 6, 7, 8, 9. Then we'll go 2, 1, 0, -1, -2, -3. Now here's what this is saying. The distance x is the distance from 3 has to be equal to 6. So here's our number 3, and I move over a distance of 6. Well, that gets me 9 to the right. But I could also go the other direction. So if I went the other direction, I went over 6. So I go 1, 2, 3, 4, 5, 6. I would be at -3. So my answers appear to be x equaling 9 and -3. Now, another way to solve this would be to say, if I assume that this is a positive value inside, the x minus 3 is positive, I could solve it by writing out x minus 3 equals 6, so x would equal 9. But if I assume that the x minus 3 is negative, then I have to multiply by -1, and I would get x minus 3 equals a -6, add 3, and x would be equal to -3. So there's two ways to interpret it. One is from a number line, and one is more of a equation type analysis. So let's try the next one. Here's solving an inequality, and we'll go ahead starting with the number line again, like we did in the last example. And I'm just going to sketch the number line one more time, and on here I'm going to put the number 2. And then I'm going to go 3, 4, 5, 6, 7, and then I'll go the other direction. 1, 0, -1, -2, -3. Now, here's the deal. It says the distance from 2 then has to be less than or equal to 4. So if I go 4 units over, I'd be at, from 2, I'd be at 3, 4, 5, 6. And if I went 4 to the left, I'd be at 1, 2, 3, 4. But the distance has to be less than or equal to. So it could be any of those numbers, but also anything in between. So when we put this all together, it appears that its x is less than or equal to 6, greater than or equal to -2. Any of those values would make this inequality true. Now, for some people, in some of their math classes, what they might have done is they would have said, well, if it's positive, it says x minus 2 is less than or equal to 4. But if it's negative, then it has to be greater than or equal to a -4. And then you just add 2 to both sides. So that would get you -2 and 6, which is the same thing. Okay, so now the reason that it's nice to know about the number line is because when they ask you to write the inequality, or write an inequality that would describe all the numbers whose distance from 8, so if I had an 8 here, is less than 5. So if I went 5 to the right, I would be at 13. If I went 5 to the left, I would be at 3. But it's got to be less than that. So then when I write my inequality, it has to be strictly less than 13 or greater than 3. Now when I write the actual inequality, I'd say the absolute value of x minus 8 has to be less than 5. And this is what would match the words that they have in the statement. The solution to that inequality would be from 3 to 13. Okay, now the last question then is very similar. It just says write an inequality to describe all the numbers whose distance from 7, so it's going to be the absolute value of x minus 7, is equal to or greater than 3. So greater than or equal to 3. And that is my inequality that I would have. In terms of the actual solution, 7 would be here. If I went 3 over to the right, I'd be at 10. 3 to the left would be at 4. It's got to be greater than or equal to 3. So then it could be 10 or more, or it could be 4 or less. So when I put this together, I would have x is greater than or equal to 10, or x is less than or equal to 4. So this would be our solution to the inequality if they want you to do that. Otherwise, you just put down the actual inequality, which is describing the words that they have asked us to describe.